Hello everyone, welcome to another problem of the Learning Royal. Today we'll be taking a look at an interesting problem from the AMC 10/12A. So let's begin. The problem reads, quadrilateral ABCD satisfies angle ABC equals angle ACD equals 90 degrees. AC is equal to 20, CD is equal to 30, diagonals AC and BD intersect at points E, and AE is equal to 5. What is the area of quadrilateral ABCD? No calculators were allowed and only about 30 minutes were given to solve this problem. Can you solve this problem? Give it a try. So let's see how to begin. First, let's try to draw this figure. So we have a quadrilateral ABCD, and then we'll draw the following. So it says AC is equal to 20, BD and AC intersect at point E, and this side is 5. I didn't write that 5 on purpose, you'll see on later. EC is equal to 15 then, and they said CD is equal to 30. Now to find the area of this whole quadrilateral, we can break it into two chunks. Triangle ABC and triangle ACD. We can find the area of triangle ACD, 20 times 30 over 2, but we need to find the area of triangle ABC. We only have the hypotenuse of the triangle. We need to find either the legs or we can drop an altitude. So let's try dropping an altitude because we already have a hypotenuse. Well, if we mark that as our altitude, and point F is the altitude's point where the altitude touches the hypotenuse, and we say that the distance FE is equal to x, then AF will be 5 minus x because this is 5. Now you see why I didn't put the 5 there. So let's see, how can we further solve this problem? We see that BFE and ECD, namely these two triangles. These two triangles are similar, as we see, because these angles are equal due to vertical angles and they both have a right angle. So, since they're similar triangles, their ratio of base to height will also be the same. So, base to height ratio in ECD is 15 over 30, which is 1 to 2. So, in EFB, the base to height ratio is also 1 to 2, which then proves that BF is equal to 2x. Let's take the triangles away. Now, before we continue on to the next part, there is an important theorem you need to know. The theorem is called the altitude geometric mean theorem, which is that the altitude of the triangle squared is equal to segment 1 of the hypotenuse times segment 2, meaning that if you have an altitude of a right triangle and you have the hypotenuse, which is broken down into two segments from the altitude, if you multiply the two segments value, it will always be equal to the altitude square. So using this formula in mind, we'll try to solve for x. So we'll have 2x whole thing squared is equal to 5 minus x times 15 plus x. If we simplify this, we get 4x squared equals 75 plus 5x minus 15x minus x squared. That simplifies to 5x squared plus 10x minus 75 equals 0. We can solve this value after simplifying a little further to x squared plus 2x minus 15 equals 0. And then we'll get that the two roots of x are positive 3 and negative 5. Well, if you see that x is the value of FE, that's our original value of x, and distance cannot be negative, so we will take out the value of negative 5. So x is equal to 3. Now plugging in x is equal to 3 in our diagram, we have these values. Now that we know the altitude, we can just find the area. So how are we going to do that? So area of ABCD, the quadrilateral, as we mentioned before, is ACD plus ABC. Now, first we knew the area of ACD, which was 20 times 30 over 2, which is 300, plus area of ABC. Now that we can solve for the area of ABC, which is going to be 20 times 6 over 2. So it's going to be 60. So now we have area of ABCD is equal to 300 plus 60, which is 360. And that's our answer. Thank you for watching the video. Please make sure to like the video and subscribe and click the bell icon to never miss an update of the Learning Royal. Thank you.